All right. So this is going to be a fresh session where we are going to cover a little bit about Java threads and concurrency programming. In the last session, we have seen an example of how we could create example thread class and example runnable object. We in fact created some examples in the last class as well. Now this is going to be one of the main classes that we are going to use again and again in this classroom. And tonight we will start with an example that is in the slide where you are going to see these methods. We are going to practice these methods. Okay, so I will start with a simple example, and that is this example where we have this print class, print character and print num classes, which are going to use just for simple printing programs. So there are two cases here. One is called print character. So we'll just create this example here and create a new Java class, and it's called print num, and this is going to print a number. It has a function called print character. Okay, so let's try to review that. After you watch the video, I want you to do the same thing and try this again yourself. So we have print num that implements runnable. For now we are not going to do the implementation, we are just going to use procedural programming last number. So probably we did in the last class itself, I think. We're just going to repeat this, so because we are going to practice the yield method and the sleep method and those things. So you have here the number that you have to print, and then you are going to create your constructor that you will use. In this case, this constructor has the same name as the class name. Those are things that you have already studied in Java. So let's insert a code of the constructor, and we are going to use this constructor. And then there's a function called print number, public void print number. Oh, sorry, that's actually the that is actually the constructor itself. Yeah, I'll just use print. Okay, so what does the print do? It prints everything from 0 to the number. Print integer I equal to 0, I is less than the last number, I plus plus, and this is a for loop, a basic for loop, and it's just going to print numbers from 0 until 100. So it will be I. Okay, like this. And this is an example of how you print numbers from 0 to the given number. This is this program without any threads. Then we are trying to create this program now. So let's go into this program, create another example. If you go into the last class videos, you will actually find we created this again. We are just doing this to repeat that. And print character, this is going to be the other program there. So we did these parts last class. That's okay. So our goal here is to recap those things. So it says here private character to print, character to print. This is a character how many times, private integer times, number of times to print it. And then there is that constructor again, so last class we have done some practice of the basic constructors. If you remember, we did some classes and we did some getter setters, we did toString method. You should have seen that, you should have tried that. And this week, the whole of this week is mainly about coding, so to prepare you for your assignment, of course. And you have this print character function, then you have again public void print method, and here depending, okay, so what it does is it's going to 0 I is equal to 0, I is less than times I plus plus, and then it's going to print this number to the number of times you have requested. What's that number? That number is character to print. Okay, character to print. I'm going to put print here, not print line, otherwise there'll be a new line after everything. So print print print. Okay, so that's going to be that. And then basically this is what it does: print num and print char, two methods, still without any threads. Or let's try to implement this. Okay, in your example here you're going to create an example print num. So you say print num number printer equal new print num, and you are going to send here number. Which number would you like to print? We like print 0 until 300. for example, and then we'll create another print char. So print char, and this is character printer, character a printer, let's call it, equal new print char. This is the way you are going to see a difference. So we are going to print a 300 times. Then we are going to do the same thing. This time we are going to print b, character b. So you are going to print character b 300 times. So this is what a small program, a very simple program that is going to print. Okay, so let's try to print number printer dot print number printer dot print. This is one. The second one is character a printer dot print dot print. So this is a basic procedural program print. So others who didn't come to the last week classes, this will be new for you, but try to follow up. Okay, we have a simple program that does basic printing. Let's see the output. As we expected, the output will be, let's wait for the output. Yeah, so it's printing all the numbers. There is a little bit issue here. Here we need to put a new line after everything. System.out.print new line. The reason is, otherwise you are going to see, yeah, look at that. So we are printing 0 1 2 3 4 5 until 300 times numbers in that range, and then we are printing a, and then you're putting b like this. Okay, so in this order. So if you change the order, for example, if you change the order here, put in the last item as the last item here, and then numbers will print the last. See, so this is a basic procedural program. What if you wanted to do this simultaneously? That's what multi-threading is about, concurrency control or concurrent programming is about. You want to do these three things, but you want to do them together at the same time. So that is multi-threading, multi-concurrency. Okay, simultaneous execution of tasks. So that's what the concept here is about. If you look at your slides here, there is some details about some terminologies, you know. So all these things are basically about that, about usage of simultaneous executions, you know, of tasks. Okay, so how do we do that? So that's what the slide is about. So this slide has shown you an example where you are seeing that the program can be run by implementing something called runnable class. So if you have the same thing and convert it into a threadable class, something that can run a task, you need to implement this interface called implements runnable. And I have shown you guys in the Thursday's class what actually implements is and what is an interface, and also we went through an example interface where we showed an example of IT policies, and we also showed an example of inheritance, you know. So last week itself we did a lot of programming on that end. So you have to go through them and you have to do some practice on those things, guys. Okay, let's go here, convert this into a threadable class. So we say implements runnable. So runnable is a Java class that's going to tell us that you are allowed to task to run as an individual task, independent of all other tasks. And because we are implementing runnable as an interface, it's going to ask us to implement the abstract methods there. So this is the abstract method that is in the runnable class, and it is forcing us to implement it. I have already told you guys what is an abstract method. We have seen in the last class during Thursday's session what is an abstract method and how an abstract class forces us to implement, and how interfaces forces us to implement features. So those are example of things that you actually need to know, and if you haven't done any Java previously, you are going to find them a little bit new, and that's the reason why I have suggested that we conduct a separate session where we could just talk about Java for a few hours, you know. Okay, so once that is approved, we will have a separate class for Java, and for now at least these things are sample programs which you can practice even after the class, right? So this is going to be the run method, and the run method is what will happen when the program runs. So this program says just run it, yeah, So it's going to run your program, and here also we are just going to implement implements runnable. And again the same thing here. What it does is implement all abstract methods, and you have your run method. What you do in the run method, it has already asked you, you're going to execute the print method. So you're going to print, so all you do is print. Now because these are independent, because of runnable, they have become actually independent tasks. Okay, so in this example you can see there is a method called task thread demo, and this is actually the main class, and we are converting this into a threadable class. So instead of running them like this, instead of running them like this, instead of running them like this, what we do is we actually run them separately as separate independent threads, as separate independent tasks. So they are going to run separately. They will not care about each other. They'll just run simultaneously. So to do that we need to create tasks, and that can be done using Java thread class. So we have a thread number one, and that is going to be task one equal new thread, and into the thread we send in this object number printer. So we are making number printer as a separate independent tasks. The same thing we can repeat 3 times. So we have 3 different tasks: task 2, task 3, and task 2 is for character A printer, task this is for character B printer. So we have 3 tasks that are running. Okay, and what we do is we are going to start them. So they are not yet started, they are not running yet. Dot start. So when you say start, like this, so you have 3 tasks and you're going to start 3 tasks, and what that does is actually going to make all of them run at the same time. So this is how concurrency is achieved. Okay, so you're going to create this, you're just going to copy paste it 3 times and say task 1 start, task 2 start, task 3 start. Once you compile it and run it, they are going to run simultaneously. Let's test it out. Okay, look at this. You have numbers followed by A's, followed by numbers, followed by numbers, followed by A's, followed by B's, and then A's, numbers, mixture. See? So this is what it is about. So if you look at this one, sometimes there's too many B's, sometimes there are too many numbers, sometimes there are too many A's, and that is because it's a multi-threaded program. So depending on which thread is executing when, and depending on how operating system is scheduling those things, it could get different, because all of these 3 tasks have the same priority. So they will just run, and whatever task has got enough resources from this processor, it will run more than the others. So that's how it works, and they are just going to be executed simultaneously. But you can already see the difference here. The difference is a simple procedural program that was printing numbers, that was printing A, that was printing B, converted it into independent 3 different tasks. Therefore numbers and A's and B's are printed at the same time, and we are just showing it into the screen. So this print method gets executed, this print method gets executed at the same time. So they share the CPU. If your CPU has many cores, then those cores are going to handle all these tasks simultaneously, and it will try to print to the screen at the same time. So that's the reason why you are seeing a mixture. And if you run it now again, the output will be different. So it will be different every time you run it. It will be different output every time, because it will be always different the way you are going to create this scenario. It's going to be always different. The multi-threading that's going to happen in the operating system is going to be different. So this is the basic example that we have created. Okay, now in the case of this slide here, where is that? Yeah. Okay, this was one of the example we did in the class, and this was an example of a graphical class, so particle class, where we actually ran some example graphical interface and showed you that even simultaneous execution occurs on graphical interfaces, and also that is achievable and possible, and it can be done, and how it is done. Then we discussed the thread class, and then started the yield method. Okay, what is the yield method? So the yield method is a thread may never get a chance to run if there is always a higher priority thread running over same priority thread that never yields. This situation is known as contention or starvation. So some of the thread is not running or is being starved. To avoid contention, the thread with a high priority must periodically invoke the sleep or yield method to give a thread with a lower or same priority a chance to run. So if you look at this example here, see, you'll see there are too many numbers. See, too many numbers. So it actually doesn't give much time for other things to run, or too many bees are running at the same time. So that means they are running and they are not giving the task they are not sharing the memory equally. So something like that you can actually enable that using yield method. So you can use the yield method to temporarily release time for other threads, you know. So every time a number is printed, the thread of print task 100 is yielded. So each number is followed by some characters. So look at this example here. After you are printing something, you are yielding. So this example can be simulated in the number. Where is the number class? This is the number class. Here, after you print something, you just thread dot yield. Okay, yield. And you can look here, thread dot yield. In this case, you are just saying, okay, you run and give others chance to run. Run and give others chance to run. So this is a way of running in a simultaneously at the same time thinking about other threads. So if you run the program now, every time there's a number, there's going to be, you see, every time there's a number, there's going to be some character. Most of the time, it will be like that. And then, of course, when all the numbers are printed, you know, now all the numbers are printed. When all the characters are finished, it's printing all the numbers. And probably if you look at this program here, you are running A 300 times, B 300 times, and 0 to 100 300 times. So you actually have the same values. We can actually reduce it to smaller number to see a little bit more common method. So if you run it now, you'll see. So see here, there is a number followed by a character, number followed by a character. And if you want, you can thread here even this one, so that they will actually share their memory equally. So even let's thread that yield here. So when they run, they wait for other tasks. So this time, always there is a character followed by another character followed by. So they share it. I mean, they run it and they wait for another task, and then the other task runs and they wait for another task. So there's a yielding, meaning it doesn't mean if it runs then another task will run. It just means run, relax, run, relax, run, like that. Okay, so in some cases it may be the same task that's going to run again, but this yield makes it relax a bit. Okay, giving space for other tasks. That's the yield method. Okay, that's one example. Now the second example is sleep. So meaning the sleep method puts the thread to sleep for the specified times in milliseconds. So for example, if you want to make some thread sleep for a specific number of minutes or seconds, you can do that. So what you do is you say thread.sleep and give here 1 millisecond. So every 1 millisecond, this thread is going to relax for 1 minute. It's just going to sleep for 1 millisecond. Okay, this is an example way to do this. So after the numbers are printed, which are above 50, then it will start sleeping. This is an example in this case, of course. So having the yield method is there. Now we can also implement it differently. So let's comment out the yield now. So we don't want to see the impact of other methods, so we'll just comment it out. Okay, let's try to sleep. So if the times that you have printed is let's say if you have already printed if times is greater than 15, you know, if you have printed that, then you can say thread dot sleep. How do you want to sleep? You will sleep for 10 milliseconds, for example, you know, or let's sleep for 1000 milliseconds. That's going to be 1 second, but then the output will not be that nice, because either way we only have very small task to do. So sleep for 10 seconds. So if you do this, what will happen is after 15 is printed, then the output will going to be little bit different. After 15 times of printing, the output is going to be different little bit. So it says here there is an error. Okay, so you have to do some exception handling. In order to sleep, you have to do some exception handling. Try to sleep. That's what it means. Maybe you are not sleepy, right? So try to sleep, and then if there is an error, catch. That's what it means here. So catch an exception. This is called exception handling, and we have I mean you should have covered some of this in Java. If you haven't done this, you'll try to do this later on. So try catch means try to do this. If there's an error, just handle it. And then exception, what is the exception? E dot get message. This is if there is an error. Okay, so now what we'll try to do is we'll try to see the output. Little bit different output will be seen. So after it has printed enough number of characters, we have implemented in the print char. So after 15 times of, after it reaches above 15, then it starts to sleep. So which is the reason why you'll see more numbers printed here at the end. See, more characters actually printed, right? So it will actually sleep for 10 milliseconds after it has printed to 15 times. So in fact, because this is too much, 2 milliseconds, you know, it's the process is quite fast because this task is something simple. It's only a print task. Okay, so you can just test it out that way. The effect is this: the sleep method puts the thread to sleep for a specific time in milliseconds to allow other threads to execute. Every time a number greater than 50 is printed, the thread of task is put to sleep for 1 milliseconds. So here also, every time a number is printed that is greater than 15, then it is put to sleep for 2 milliseconds. Okay, so that means every time a number is printed, every time a character is printed greater than 15, then it's going to do a character followed by a number, a character followed by a number. Okay, anyway, let's try to do that in this case. Yeah, if times is greater, we remove this and move to the number. Here, just try to sleep. So if the last number is greater than 15, so if the number is above 15, then that number will always be followed by a character. That's how we have applied it, but you can see here the output is not the same. So if it is greater than 15, it's oh, this is wrong, it has to be I. If I is greater than 15, guys, so that was the same mistake here we did. Let me just repeat it again. If I is greater than 15, so every time it prints a character after printing 15 times, then it's going to send a number together with it. Yeah, this is more like it. Okay, so after it has printed 15, it's going to give more time to the numbers, and this will be more visible in the case of numbers because there is only one here on task, and that is printing of numbers. So if I is greater than 15, then sleep for 1 millisecond. That means every time you print a number greater than 15, also allow a character to be printed. Yeah, something like this. So 18, 19, 20, 21, they haven't done any printer. Let's run it again. Yield method was much better in that sense. So we could actually let it sleep for more 100 milliseconds. So it takes more time to complete. If I is greater than 50, let it sleep. Right. So print and then sleep. Yeah, anyway, the effect is not that vivid, but you understand, you have to try it out like that. Okay, so the join method here, the join method is actually to make threads run serially. That means you let one task finish and then you will let other tasks continue. That's what it actually means. So for example, how do you do the thread? In this case, you do the thread by, look at here. In this case, you have task 1, task 2, task 3, and what you will do is, let's say task 2 dot join. What it does is, it says it has to join. Again, you have to do try catch block here. Try to join it. If there's an error, catch it. Okay, so this is just basic things here again. Okay, what it does is, it waits for task 2 to finish before doing anything else. So what is task 2? Task 2 is printing character A. Let's try to see. So all A's will be printed together. See, this is what it is. And then other tasks will run. So it lets A. So what this means is, let task 2 finish its work. Don't interrupt task 2. That's what it means. See? So it continues at once without getting interrupted. See? Okay, so that's the idea of this join method. So you can use join method to force one thread to wait for another thread to finish. So we are forcing all other threads to wait for task 2 to finish. Okay, that's the idea. And of course, this is another one, is giving priorities. So higher priority threads run more than other threads. So for example, let's say, because we are seeing more numbers, we could say, let's give this one a higher, let's reduce the task 1's priority, which is a number printer. Number printer, we can give it the lowest priority, so minimum priority. So let's say task 1 dot, I'm going to remove the join section because we have already tested it just now. Task 1 dot set priority. And what is the priority? The priority is a number, of course. It is minimum priority, which is also equal to 1. So you can just say 1, which is going to be minimum priority. And with minimum priority, now these tasks will run more than these tasks. Let's try to verify that. So the thread class has int constants, normal priority, minimum priority, and maximum priority, representing 1, 5, 10 respectively. The priority of the main thread is normal priority. So JVM always pick the current runnable thread with the highest priority. A lower priority thread can only run when there is no higher priority thread running, something like that. So this is an example way to play around with that using priority. Okay, let's try to run it now. So we expect that task 1 to have low priority, so it will wait for others to finish. So number printer will be at the end. So let's wait. See, A's finish, B's finish, and then only numbers gets executed. Again, let's try. A's finish, B's finish, A's finish, and then numbers. So this is because it has the lowest priority. You see, it has the lowest priority. So that's kind of how you are going to play around with these things, guys. Okay, so we just wanted to cover that is the first part of this lecture. And those who are absent for the last class, please go back and review the first lecture, review a little bit of the videos, and also review a little bit of what we have done tonight during this class. And that's going to be